Hello, Algebra 2. This is Lesson 7. This is from Section 5.2 when you see the file name. The first thing is a warm-up, and it says work with a partner. Some of us are at home. If you have a partner and you're at school, you're more than welcome to use them. This is just a review of the things that we have been learning. So pause your video and try each of these. Then unpause it and check your answers. I will go over these next. Okay, question A. 5 to the 2/3 multiplied by 5 to the 4/3. I need to zoom in here. I can't write very clearly. Fix that. Okay, so we've got the same base. So since we're multiplying same bases, we add the exponents. 5 to the 2/3 plus 4/3. All right, and then from here, we already have common denominator. We get 5 to the 6/3, which I will reduce to 5 to the 2nd, which is 25. All right, question B. 3 to the 1/5 times 3 to the 4/5. Same base, so we multiply the bases. When we multiply the bases, we add the exponents, but the base is still that same common base. So 1/5 plus 4/5 is 5/5. Sorry. Oh gosh, I can't write. 5/5, which equals 3 to the 1st, which is 3. All right, and question C. Got 4 to the 2/3 and then to the 3rd power. So here I've got a power of a power, and we are going to multiply those exponents, and you multiply fractions straight across. So we get 4 to the 6/3, which is 4 to the 2nd, which is 16. All right, question D. 10 to the 1/2 to the 4th. Okay, again, I'm going to multiply those fractions, those exponents straight across. So I'm going to get 10 to the 4/2, which is 10 to the 2nd, which is 100. All right, question E. Oops. 8 to the 5/2 divided by 8 to the 1/2. When we divide like bases, we use that like base and we subtract the exponents. So we get 8 to the 2nd, which is 64. Okay, and then question F. 7 to the 2/3. Oops. Over 7 to the 5/3. So we have like bases of 7. We're going to subtract the exponents, 2/3 minus 5/3. So that gives me 7 to the negative 3/3, which is 7 to the negative 1. And then remember, negative 1 means to reciprocate, so we get 1/7. Okay, the next thing in our notes is just a reference sheet. You need to start memorizing a lot of these. I would say that probably won't see many of these if it's on a non-calculator section. probably won't see many of these on a non-calculator section. Maybe. But for the most part, I'm going to stick with the ones that I didn't put a box around for the non-calculator section. If it was a calculator section, you can just use your calculator to find that information. All right. We're going to simplify radical expressions, and today we're multiplying and dividing. Sorry, multiplying, dividing radicals. And then we're not going to do what's called rationalizing. That will be another lesson. So if we're going to use multiplication or division, we have an expression that involves a radical with an index n, is in simplest form when the expression meets these three conditions. None of the radicands have perfect nth powers, so we have pulled all of those roots out other than one. And then none of the radicands can contain fractions, and no radicals appear in the denominator of a fraction. And then to meet the last two conditions, we're going to do something called rationalize, but that's not going to happen today. If the index is the same, you can multiply or divide the value underneath the radical. The index does not change. So here's the two properties for today. We've got the product property and the quotient property. The product property says if we have the root of two numbers that are multiplied, we can separate them to be the root of those numbers separately. And we've done that already. We've done something like square root of 20 is the same thing as square root of 4 times square root of 5. But the product property allows us to also multiply them back together. So if I gave you the square root of 4 multiplied the square root of 5, we would rewrite that as the square root of 20. But that works for all roots. So if I had the fourth root of 2 multiplied by the fourth root of 3, we would have the fourth root of 6. So we would multiply those back together. The quotient property is just like the product property, only it involves division instead. So here we have the quotient underneath one radical, and you can separate that to be separate roots on top and bottom of the fraction, but it goes both ways. If they are already separated, we can combine them as long as they have the same index number, that 4 right there. As long as they have the same index number, we can combine them under the same radical, which allows us to divide 162 by 2, giving us 81. And then the fourth root of 81 is 3. So this is one way that we could use to kind of simplify our radicals. This next part says multiply the like parts together and simplify. If I had something like 3 third root 5 multiplied by 7 third root of 2. We can only multiply the stuff that's in the same locations together. So 3 and 7 are outside of the radical. I can multiply those together. And underneath the radical, we've got a 5 and 2. So I can multiply those together. This would simplify to be 21 cube root 10. So here we're going to use properties of radicals with multiplication to simplify each expression. I'm going to zoom in. I'm going to go through each one. Okay, the cube root of 135. So I want to break the cube root of 135 down into smaller numbers, and hopefully one of those numbers is a perfect square. Let's see, I know 135's got to be divisible by 5. And since I'm not using my calculator at the current moment, I'm doing it by hand. Be 2, be 3, 27. Okay, so I can separate this to be 27 times 5. From there, I can separate it to be the cube root of 27 multiplied by the cube root of 5. And the cube root of 27 is a perfect cube, 3. But the cube root of 5 does not simplify any further, so I will leave it as cube root of 5. 3 cube root 5. Question B. Here we have two radicals that are being multiplied. They don't have the times symbol in there, but we should know that's multiplication. So I'm going to make one big radical, and I'm going to multiply 10 times 14 times y times y. So I'm going to get 140 y squared. Now, we need to see if it can be simplified. So if I separate this to square root 140 and square root of y squared by using that product rule, I know that the square root of y squared is y. But what about the square root of 140? Does that separate into two radicals, one of them being a perfect square? I know 4 goes into 140. Well, I think it goes into 140, I should say. Pretty sure it does. I'm sorry, I'm tired. There we go. 35 times. And then 35 is 5 and 7. So 4 is the only perfect square that goes into 140. So I'm going to have 2, I'm going to have a y, and then we'll have the square root of 35 for our simplified answer. All right, question C. I'm going to multiply the things that are in the same location. I can multiply the -2 and the 4 and get -8. And then cube root, I'm going to multiply 12 times 18. See, 12 times 20 minus 12 times 2 is going to be the same thing as 12 times 18. So 240 minus 24 is 216. Is that correct? Yeah. So I've got -8 cube root of 216, which I have memorized. That is an actual cube root. It is also on that chart on the previous page. The cube root of 216 is 6. And then -8 times 6 is -48. And we have it simplified. Too far. All right, question D. Multiply the things that are in the same location together. We've got 2 times 3, which is 6. And then I've got the cube root of 9 times m to the second. So 6 cube root, 81 m to the third. All right, I'm going to separate this cube root of 81 and the cube root of m to the third. The cube root of m to the third is m, but cube root of 81 is not a perfect cube. So 27 divides evenly into 81 3 times. And that 6 is still multiplied out front. So I get 6 multiplied by 3. I'm going to bring the m in front, and then I've got cube root of 3. I'm going to just go ahead and simplify that one step further. 18m cube root of 3. All right, question E. They're both cube roots, so we'll go ahead and multiply what's underneath them together. We're going to have 3 times 36 times x times y to the third. So 3 times 36. $108. Oop, and I forgot my cube root there. 108 x y to the third. So I'm going to go ahead and separate these. The cube root of 108 multiplied by the cube root of x multiplied by the cube root of y to the third. Well, the cube root of y to the third is y. The cube root of x cannot simplify, so that's just going to come down just as itself. 108, that is not a perfect cube. And I wonder if there's a perfect cube that goes into it. Let's see, we've got perfect cubes are 8, 27. Wait, how did we make 108? We made 108 by 3 times 36. So 3 times 36 is 4 times 9. Oh yeah, I can see it. 27 must go into 108. So many times? 27 is going to go into 108 4 times. So that becomes a 3, and then this guy just has to stay the same. So let's see, what do we have for our final answer? We've got a 3, a y, we have a cube root of a 4, and an x. So we'll go ahead and put those together. And that's our final answer for that one. All right. Just multiplying a 5 by the rest of this. So 4th root 5 times 125. You know what I might do? I might change 125 into 5 to the 3rd. And then when I go to actually multiply 5 times 5 to the 3rd, I get 5 to the 4th. Then I've got x to the 8. I've got y to the 12th. And I've got z to the 4th. So now I'm going to separate each of those. And we'll have the 4th root of 5 to the 4th multiplied by the 4th root of x to the 8th multiplied by the 4th root of y to the 12th multiplied by the 4th root of z to the 4th. Now I'm going to use the rational exponent notes that we did last. And I'm going to change all of these, just for fun, I'm going to change all of these into rational exponents. So I'm going to do 5 power of 4 over the root 4 multiplied by x power of 8 over root 4 multiplied by y power of 12 over root 4 multiplied by z power of 4 over root 4. Now you can see they all simplify really easily. We get 5 x to the 2nd y to the 3rd, z. Simplified. All right, question G. Okay, both of these are square roots and both of these are cube roots. So I can only multiply together the square root of 18 and the cube root of 27. I cannot multiply these two roots together because they don't have the same index number. So I'm just going to simplify what I have. See, square root of 18 can be square root of 9 and square root of 2, which is 3 square root 2. The cube root of 27 is a perfect cube, which becomes 3. Now that both 3's are outside numbers, we can multiply them together. 9 square root 2 is our final answer. Okay, question H. So these are both square roots, and that one is a 4th root. So square roots, I'm going to multiply those together. 15 times 3 is 45, and then y squared. And then we've got the 4th root of 16, y to the 4th. Okay, so 45, I can break down that square root to be 9 and square root 5, and then square root of y squared is y. The 4th root of 16 is 2. The 4th root of y to the 4th is y. So anything that's, I didn't finish this one. 3. Anything that is not under a square root, we're going to combine together. Anything that is still under a square root will stay under that square root. So I have 3 and 2, which is 6, and then y times y, so y squared, square root 5. Question I. Okay, so these are different roots. So can't really multiply them together. I could change it though to 2 to the 1/2 multiplied by 2 to the 1/4. As soon as I change the form, now we have like bases that are being multiplied, which means add our exponents. And then I look at my exponents. They do not have a common denominator, so I need to give them a common denominator. I'm going to multiply this one by 2 over 2. So I get 2 to the 2/4 plus 1/4, which equals 2 to the 3/4. Now, since the original was in radical form, I'll put my final answer in radical form, and I'll have the 4th root of 2 to the 3rd, which is the 4th root of 8. Sometimes I just think math is so interesting where you could start with this and end up with something that like doesn't look like it at all. I find that interesting. All right. And then the next section, or not section, the next question, J, is x plus 2y, or square root x plus 2y, square root x minus 2y versus square root x plus 2y times square root x plus 2y. Okay. So everything's under the square root. You're going to multiply this stuff together under one square root. So I'm going to have x plus 2y times 2y times x minus 2y here. And then over, I'll do that one in a second. Okay. So then I'll go ahead and multiply those together by FOIL or by the grid method. If you want to draw the box, it's whatever method you want. I'm going to go ahead and do FOIL. So x times x is x squared. And then I get minus 2xy. Then my inner is plus 2xy. And then my last is minus 4y squared. Okay. Woo. And then my next step would be those terms in the middle are like terms. One is plus 2, one is minus 2, so they're going to totally cancel out. And I'm going to get the square root of x squared minus 4y squared. Now, you cannot take the square root of the x squared and the 4 and the y squared separately. You cannot do that. This is as far as you can go. And I have kind of I don't know if you're gonna understand it or not, but I kind of have an example that I always pull up when people take square roots wrong. Like from geometry, a squared plus b squared equals c squared. We should know that 3 squared plus 4 squared equals 5 squared. That's a triple that we always use in geometry. And if you haven't taken this part of geometry yet, if you're double blocking, then you will learn it. But there's a triple for a right triangle that is 3, 4, 5. And if we do the Pythagorean theorem, 3 squared plus 4 squared equals 5 squared, it will work out. I will get 9 plus 16. I'll get 25. 9 plus 16 is 25. But what if we were to square root both sides instead of simplifying? What if we were to square root both sides? Could we square root the 3 and 4 separately? Could we write 3 plus 4 equals 5? That doesn't work. So you're not allowed to square root unless you're square rooting the entire thing. You cannot square different terms. This will not work. So what I had to do is I had to actually square them and then add them together before I could like square root 25 and get 5. I would have to multiply it all. So that's kind of what's going on here. We can't, sorry, I keep overdoing that. We can't square root these pieces and then try to subtract them. It will not work. So this is as far as we can go. All right, so that was versus this one here. Oh my gosh. I'm sorry, guys. It's like zoomed in a little bit too far. My screen's going crazy. Okay, so compare that to this one here. This one will have x plus 2y times x plus 2y, which gives me x plus 2y squared. Now, I could FOIL this, but I'm not going to, because what I did when I combined them is I now have the square root of an entire thing that is squared. So it doesn't even matter what's under here. I don't care what's under there. If I have the square root and the squared, they're inverse operations and they undo each other. So now let me bring back what I had there. So because they undo each other, we get x plus 2y for our answer. So you can see I was allowed to do it when the entire parenthesis was squared, but when it's individual pieces around a plus or minus sign, you can't square root. Okay, the last section, I think is it the last section? I think it's the last section. Yes, last section is division. Okay, and this is going to be similar to multiplication. The rules are similar. They're just on top of each other instead of next to each other. We're just dividing instead of multiplying. Here we go. Question A. These are separated. I cannot take the fourth root of 5 or the fourth root of 80, but maybe I could take the fourth root of 80 divided by 5. So I'm going to divide 80 by 5. And I get the fourth root of 16. That is a perfect fourth. It's 2. Question B. These are both under a square root. So I can separate these to say, what's the square root of 25 over the square root? Nope, I'm not going to do that. I lied. Sometimes we make mistakes. I'm just going to divide 25 by 5. And I get the square root of 5 over 1, which is the square root of 5. And you can't really do anything other than that. So that's it. Okay, question C. We've got the cube root, and we've got a fraction. 1,000 will not divide by 27. A's and B's won't divide. So maybe I will break it apart to be cube root of 1,000. Cube root of A cubed. Cube root of 27. And cube root of B cubed. So I undid the multiplication on the top, and I undid the division from top to bottom. The cube root of 1,000 is 10. The cube root of A cubed is A. The cube root of 27 is 3. The cube root of B cubed is B. And then there's nothing else to simplify. All right, so this one has some like pieces. 4 and 2 are both numbers not under the radical. So I can divide 4 and 2, and then I can also do cube root of 81 over cube root of 3 kind of separately. So 4 divided by 2 is 2. Now this, the cube root of 3, there isn't one. Cube root of 81, there's not an even one. But if I combine them into one cube root, those will divide. So we'll get 2 multiplied by the cube root of 27. So 2 times 3, which is 6. Isn't that crazy that, let me erase this right here. I just think that's just so interesting that this equals 6. Like it totally doesn't look like that would equal 6, but it does. It equals 6, unless I made a mistake, which I've known to do. All right, question E. All right, both are fifth roots. I think I'm going to combine one big fifth root, 64, a squared, b to the 6, over 2, a to the 7th, b. Now, I'm going to think about this being the fifth root. So what I'm going to do right now is kind of factor this. I'm going to break apart the pieces by multiplication. So there's a multiplication sign here, and there's a multiplication sign there. So I'm going to break those apart to be fifth root of 64 over 2 multiplied by the fifth root of a squared over 7 multiplied by the fifth root of b to the 6 over b. So I'm going to look at each of these separately. To me, that's helpful for my organization. All right, so 64 over 2 is the 5th root of 32, which, by the way, is 2. For the next one, oops, I forgot my a. Let me just erase that and fix it. Okay, so here I've got a, just underneath the root, I've got a to the 2 minus 7. Okay, so that's a to the negative 5. So that's 1 over a to the 5th. And that's under the root. So we've got the 5th root of 1 over a to the 5th. So the 5th root of 1 over a to the 5th, well, no, I'll do it right now. Okay, so that would be like the 5th root of 1 and the 5th root of a to the 5th, which is 1 over a. All right, the third one, we've got b to the 6 minus 1, which is b to the 5th, and that's under the 5th root of b to the 5th, so that would be b. So we've got 2 times 1 over a times b. So I want to multiply all that together. I get 2b over a. All right, this one's similar. They're square roots. I'm going to separate them to separate kind of square roots. 189 over 7 multiplied by the square root of x to the 4th over x to the 2nd multiplied by the square root of y to the 7th over y. So 7 goes into 189. Let's see. That would be 2 times the remainder, or 29 times. So I get the square root of 29. And then here I'm going to subtract my exponents, 4 minus 2, and I'll get the square root of x squared. And I will subtract my exponents, y to the 7 minus 1. So I'll get the square root of y to the 6. Okay, square root of 29 I can't do anything with. Did I do it right? It's really 29, huh? Okay. Square root of x squared is 2. No, is x. All right, and then this one here, maybe I'm going to write this as rational exponent form. Y to the 6th power over 2 root equals y to the 3rd. Okay, we do not leave the square root 29 in front. We put it at the end. So I have x, y to the 3rd, square root 29. All right, last 2 examples. Oh, we can't do this one yet. That must be the, can't do it yet. This one we can. I don't know why we can't do that. Why this one's in here. We can't do anything yet. We need to rationalize this. But haven't learned it. Now you should have learned it. You know what? I'm just going to do it because you should have learned it in Algebra 1. And we are going to spend a section on this. But let's just go over it real fast. This is a pretty basic one. We're going to multiply by a value of 1. It's a value of 1, so it does not change the value of the expression. This is just like finding a common denominator. We multiply the top and bottom number by the exact same thing. And I'm going to multiply it by something that will give me a squared square root in the bottom. So I'm going to multiply by square root 3 because that will give me the square root of 3 squared, which tells me the answer is 3. On top, 7 square root 3. Can't really do anything with that. 7 square root 3 is the answer. So that's rationalized, which means no radical in the denominator. Now, we will do like a whole section over that. So that was just one example. All right, last one. Let's see, square root of 9 can be simplified. So we get a cubed square root 3 over a times 3. Now we can simplify if they have the same basis, like the a's. We can do a to the 3 minus 1, which is a squared. But these are not the same. One's a radical, one is not. So the square root of 3 stays the square root of 3, and the 3 by itself stays a 3 by itself. All right, that's it for the notes today. Make sure you ask questions if you have them, and then go ahead and start your worksheet. Have a great day.